Welcome to Chapter 11's lecture. This is on the horizontal control survey. And once again, and we're going to find this out throughout the rest of the book, the book goes into some in-depth discussions and explanations that aren't really necessary so much for the construction surveyor. So hopefully we hit the highlights well enough for you. And there's a lot of things in this chapter that I'm not going to ask specifically about. I want you to have an understanding more so than specifics. So let me go ahead here and share the screen again. And there we are. So again, Chapter 11, the control survey. One of the things that you have to realize now, and the book points it out, that is that we once surveyed, statewide. Our best surveys were once done on a state level or even national level as being the control networks for the country or for a state. Now our surveying, because of GPS and all the aerial technology and the satellite imagery, is global. So we need to have something that represents the Earth. We know about latitudes and longitude. The longitude of the long lines from north to south pole, zero, or the beginning of it, is Greenwich, England. That's the prime meridian, and at that point is where we base our time from. There's 24 of these long elongated circles around the Earth, and that creates the 24 hours. Each one is roughly a time zone, but not quite true. But you get the idea that that's how things work with the longitude. This particular sketch sort of shows you some other features. One of the things that happens is we need to measure what is not a perfect circle or a perfect sphere. And we end up getting into the ellipsoid, which is a representation or a model of the Earth's surface, but not exactly correct, but a representation of it. This type of surveying method was something that used to be used a long time ago. The book talks about triangulation and trilateration. Those types of surveys are not used anymore. Now your control is being done with GPS or precise traverse, precise or precision control. Maybe the book might speak of it, but that quality traverse done with a total station or done with GPS receivers. So you don't need to worry about this. You don't need to worry about triangulation or trilateration. The federal government produces a chart that has expectations of the quality of surveying. So this is something that's kind of old, and it's something that you're not going to need much of. I can tell you that. You won't need to, you're not going to be asked about it, but just realize there's different qualities of surveys and that the federal government establishes the parameters of it. The same thing here with this precision, positioning accuracy. That's a least squares solution that we've talked a little bit about, and that's generally what your GPS is doing. It's a least squared solution. But you can see that this right here is 1 in 100 million. So for every, to have a AA Harn reference point, its accuracy has to be the same as 1 foot and 100,000 feet. That's cutting the globe open and laying it out 4 times, and the accuracy is 1 foot within that. So you can tell that it's really, really accurate. Most of the time, surveyors, when they do surveys, are in this 20 to 100. So for every 20,000 feet, I'm off 1 foot. Sounds like maybe a lot or to you, but let's take this down to a mile. So in 1 mile, you would be off about 3 inches. Up here, commonly I do control surveys that meet this mark right here. So this is in 20 miles, I would be off like one foot in 20 miles. And you break that back down, you're you're like in the 3 inches in a mile, or 2 inches in I guess something like 1.5 or 1 inch in a mile. It's really, yeah, like 1 inch in a mile. That's what this one would be. So you see that your accuracies are pretty good. I mean, if you're off 1 inch in a mile, that's really pretty accurate. You know, it's really good enough for construction. It's good enough for surveying, let alone general construction work. Your elevations generally are done 2 ways now. Precise leveling, we still would use level loops and the level rods, and I've talked to you about that. We did that in the first part of the course. We still use that for running elevations and controls, because we do have a little problem with GPS. I'm not going to get into all the different techniques. If we met in person, I would show you some things and I would explain it differently. But for what you're after and what you're going to do surveying wise, it's involved in construction management. Yeah, you just need to know that these two methods are how you establish elevations and the control surveys related to your elevations. Control surveys, here they're going to give you these methods. You can forget about triangulation and trilateration. Just don't do that anymore. I haven't done it in a long time. We do precise traverses and GPS. That is the only 2 ways that you set up your control surveys any longer. The other methods are not in play. The book's going to begin now to get into some Lambert, and the other one is the Mercator projections. These are just 2 different methods of projecting the Earth's surface and how it works as far as putting it on a state plane coordinate system. That's what we're after. We're after taking your state, and in this case, we're in Maryland, but we're close enough that if you're doing construction work, you might be in DC. Excuse me. But you might be in DC or you might be in Virginia, and you're going to have a different coordinate system. So that's really what you're after here, is the coordinate system. You don't have to know how coordinate systems are made, whether they're Mercator or Lambert projections, but just realize that man is trying to mimic the shape of the Earth and make it specific to a state. And see, here's the transverse Mercator projections. So that's not that important for you. Just realize that the whole purpose of this is to get it on a state plane grid. And when you deal with a state plane grid, you have a scale factor. You'll have to worry about this if you go a long ways. So surveyors worry about this if they go a mile or 2. You might have to worry about it. The biggest place I could think is if you're doing road work or highway work for miles, or if you're doing some transmission lines or power lines that would take miles of work. And at that point, then you need to worry about the scale factor. And generally what happens is, as you take a measurement on the Earth, let's say you shoot something and it's 1,000 feet away, the grid distance for it is going to be like 999.99 feet. That's what happens with scale factor. Maybe, maybe a couple, another inch or so off of that, but it's going to come up being somewhat shorter when you put it on a flat plane, or the coordinate system, the state plane coordinate system. And again, here we're talking about coordinate systems, whether it's transverse Mercator or whether it's a Lambert projection. Your software is going to tell you that, and it's going to be state specific. unless you're doing something maybe in Europe or Asia or something, you're not going to use the UTM system, that Universal Transverse Mercator. You're going to be state specific for most of what you do. Here, nobody's going to ask you about this, but you can see that here in Maryland, we are a Lambert system. Virginia is also a Lambert system. Washington, D.C., they sort of cheat off Maryland and Virginia. They don't really have their own state plane coordinate system. They're very small, and I think in most cases they're probably designed using Maryland coordinates. You know, and just keep in mind here that you have this ellipsoidal height. We're still working off a GRS 80 ellipsoid. That means 1980 as far as a ellipsoidal shape. So we're still working from that, but we got to get this distance in between that we're trying to survey. So we're always making these corrections to get from the ellipsoid to the ground. Again, you don't need to worry about that part of things. The grid coordinates and elevation factors, grid coordinates, and here the slides will go through things. You don't have to worry much about this because you have software and your sites are going to be small. Unless you're, like I said, unless you're going to run a road, if you're going to run a few miles of highway, you know, maybe 2, 4, 10 miles, you need to take into account then your grid factors. And you need to take into account elevations as well, because they're going to change based upon what you measured on the ground, what it needs to be, you know, in the grid system. It's going to change. I have had to use it for a couple times. If any of you are familiar with Charles County, and I know a couple of you might be, I surveyed from the beginning of 488 and 301 in La Plata, or not in La Plata, I'm sorry, in Bryantown. I surveyed all the way down 488 to the town of La Plata, and then I turned and ran behind, I think that's Robert Stephen Park. I turned and ran behind the park over to St. Charles Parkway, from St. Charles Parkway up to 301. It was many miles. I did that for Smeco Power Company and the transmission line, and it was many miles long, and my survey was terrible, absolutely terrible. My results were horrible until I applied my grid factors and converted things from ground to grid. I had gone so far that I had to take into account the curvature of the earth. And that's what the ground and grid conversions do. You're never going to be asked about scale factors like this. But again, just remember that when you're shooting things on the ground, they measure one thing, but the longer you go on the grid, the more they have to change to continue to reflect what the grid is doing with the coordinate projection. In our case, in Maryland, the Lambert, Virginia's the Lambert. So that projection and the ellipsoid versus being on the ground, we have to accommodate for it. Again, your software is going to do that, whether it's your GPS receiver or whether it's your AutoCAD. For the most part, you're going to be able to take care of that. And I would say that if you're a construction company and you're doing miles of work, you're hiring a surveyor to do it. You're not trying to do much of that on your own. And but you'll have to, you know, just kind of have an idea that things need to be adjusted when you go further and further away from the beginning. There's a combined factor that it handles. The combined factor handles the actual distance, you know, from A to B, as well as the elevational difference from A to B. So we actually use a combined factor most of the time. Coordinates, again, they converge. Do I get you don't even need to worry about any of this. What I'm looking for is right here. All right, so when you talk about convergence, we're up here someplace, this ground distance right there. And as we put that on a flat plane, we begin to come back in toward a very tight angle. So you can tell like this distance is nowhere as close to this one. And that's why we have, me go back. That's why we have this grid coordinate convergence, meaning that the flat plane that's up here, as you change in elevation, gets smaller, and we have a convergence. As the lower you go, the tighter these coordinates actually becoming, the x and y's. This same piece right here, when you get down here, it's shorter, and here it's shorter, and down here it would be even shorter, but it's still the same grid coordinate up here. So that's why you have to take into account a convergence factor. And once again, your software has that in play. AutoCAD handles that very well. This stuff here is not too important. It's talking about control surveys and various ways of control layout and the types of networks you can have. The precise surveys that you're going to need are really those traverse loops that we talked about before. This type of work here is really not what's used today. But a traverse with the loop and running it through the points and locating as much as you can, that's your precision control. Otherwise, we're going to do everything we can to take GPS on all of this and call it a good day. You don't need to worry about this part here as far as notes go. Again, the book talks about the handwritten notes, but we understand that we're dealing with data collectors nowadays. Accuracy requirements for layout surveys. I'm going to give you in a nutshell. If I was to survey something like this, and I was to stake out these, we're calling it all these three buildings, one building, two buildings, three buildings. Let's say this building here was going to be built on a concrete foundation and, you know, come up off of a footer with some sort of block wall, and then we put some wooden, you know, some 2x6s on it or 2x8s, and we build ourselves a structure. The accuracy here would be each one of these corners would need to be staked out to about 1/4 of an inch. Half an inch would probably be okay. Anywhere within a half an inch would be all right, but you can do better than that. Over here, let's just say this is a big building with steel columns in it. These steel columns, if you're staking a large building like that, those columns, the center of them for the bolt pattern, really needs to be at an accuracy level of 1 inch equals, or 1/4 inch, or preferably 1/8 of an inch. We can measure with the right equipment. We can get below 1/8 of an inch, but most surveyors don't have that kind of equipment to get better than 1/8 of an inch. And if you think about measuring 1/8 of an inch from here over to here, well, that's really pretty accurate, because if you're trying to pull a measuring tape and measure 1/8 of an inch, you can do it, but it's usually the thickness of the blade you're going to cut the 2x4 with. So, you know, that's what we're talking about, is accuracy for any of these points on the perimeter of a building. So you don't need to be too concerned about, you know, this type of stuff here for accuracy requirements and how you get it. Just know that when you're surveying and you're going to do construction work, you should be in the 1/8 to 1/4 of an inch as far as accuracy goes. That would be 0.1 to 0.25 hundredths of a foot. So, or 0.025, between 0.01 and 0.025 is where you should be at for your accuracy. So that wraps up chapter 11. It's again, we'll stop that screen share. You get the whole face. So understand that, you know, there's a need for the coordinates, but your software is going to handle it. It's too complicated to not deal with in software in today's world. The other thing that is coming up is 2022. There's going to be a whole new coordinate system that is going to link the entire United States in one coordinate system. And so that's coming. And so it's going to be something a little bit different, actually a lot different as far as things go on the ground and as far as surveyors measure. But again, your software is going to handle that. If you guys have GPS or machine control, some salesperson is going to help you reconfigure it, and you're going to get the right answers once we get to a new coordinate system. So I'm going to go ahead and stop this thing, take a break, and when I come back, we'll be looking at chapter 12, which is machine control.